Today we are going to do section 10.7, which is graphing parametric equations. Now to do the graphing, we're not going to do what the book says, which means the book wants you to do it the old-fashioned way, which means you draw big long charts of points and then you have to plot it one at a time, and I didn't even do it in my day, okay? I don't remember what I did, but I do remember that I didn't do that because that is just way too painful. Nowadays, we have something wonderful called Desmos, which you can just type it in and type in the equation, everything will come right out. So before we start doing stuff, let's look at one of these samples. This is problem 51 of this section, but I'm using it as a sample. Now, this is a screenshot of the Desmos website, which I will also put it under the video description. And for problem 51, where x is equal to sine of 2t and y is equal to sine of 5t. Okay, that looks kind of fuzzy. Why is it so fuzzy looking? Well, anyway, so the point is, and let me check. I think that looks a little better. Anyway, the point is that when you type in the parametric equations, what you do is you type in parentheses, okay? And then type in the x value, like x of t equals to, in this case, sine of 2t, and then type in comma, and then type in value for y of t, which in this case is sine of 5t. And then the Desmos will automatically put out the range for t, like where do you want t to be. In this case, it put in t equal to 0 to 2 pi, but you can change both values, 0 or 2 pi, to whatever you want it to be. You can change t to, say, 50 and change 0 to the negative 100. Whatever you want, okay? And so once you type that in, the Desmos will automatically, immediately plot the graph right there for you, okay? This happened to look very, very nice, isn't it? And look at that cute little thing, whatever that might be. And so that is how so that's all you have to do for this section is, and please type it in, okay? Whatever it is that you need to, that you're supposed to plot, just type it into Desmos with x. And remember how it's done though. This is, well, first try this one, okay? If you type it exactly like it sees here, parentheses, sine 2t, comma, sine, parentheses, 5t, close parentheses, every bit exactly like you see here. Now, and also I wanted to say a little bit about Desmos. They have really cool features here that's really intuitive to use. For example, if you want your graph to be bigger, push the plus sign. If you want it to be smaller, push the minus sign. Okay, and by the way, to type in sine, you just type in sin. That's it, and then 2 and t and all that stuff. Now under Desmos, there is a little keyboard symbol. If you click it, it will open up this keyboard here. Normally this keyboard is shrunk down at the bottom. You just have to click the little symbol to open it up. And once you have the keyboard, you'll be able to type in things like here, absolute value, or squared, okay, or square root, or pi, and you can move stuff around with certain arrows. Like when you're typing, sometimes you're stuck under the square root sign and you want to move, just push the arrow keys and then they'll get you to move. And of course, that's true on the regular keyboard as well. A keyboard also have these buttons that you can push, okay, that specifically to raise to something to a power, like to raise it to be squared, okay, you push shift 6, because shift 6 has that upward arrow there that points up. That is used in math to be for typing in power. And or you can just use this thing right here, okay? There's a symbol right here for you to use. I'm talking about this thing. Right. So for anything squared, and I'm sure there are many. Desmo also have their own tutorials and stuff, and you can look at those if you have any questions. But for the most part, they're very, very intuitive, and it doesn't take long for anybody to just pick up on it right away because it's an excellent program. So that is that. And having said that, then the next thing I want to do is I want to talk about homework. Because this section, there is unless you want to plot everything by hand, which I am not going to tell you to do that. Okay, so for homework, I want us to redo some of the examples from the previous section, because in the previous section we started talking about parametric equations, but we didn't do much plotting or figure out how to do it. So let's do that now. So for homework, please do the examples on page 971. That's the previous section. Examples 1, 3, 4, 5, 6, 7. And then in the current section, please do examples 1, 2, 3, 4. And then for homework, the later homework, then in the homework section, please do problems on page 990, problems 15, 33, 35, 47, 51, 53, 54, 59, and 71. And this is problem 51. I don't mind showing it to you because your homework in this section really is just about typing in the equation, which shouldn't take long. Okay, then so all these homework shouldn't take long. The purpose of it is just to get you to play with decimals and maybe move the stuff around. Like for example, there's a sine 2t here, right? And well, if you change it to say sine 3t, how would the graph change? That's the kind of stuff you can do to see how things can change to make it look different. Okay, or something else. For example, that number t down here. It goes from 0 to whatever it is, 2 pi. And well, what if you changed it from 0 to pi? What would the graph look like? Or even from 0 to 0.1, and watch the graph increase as you increase the t. Just play with it a little bit and enjoy this awesome thing, and count your lucky stars that you don't have to do this by hand. Well, I never had to do that. Well, I know I didn't. I don't know what I had to do, but I sure didn't do it. So life is so much better now. Okay, and so now that I've said you know the homework, now I will show you the I did quite a bit, most of the homework myself, and so well, it didn't take much to do it. So I enjoy doing this. Okay, this is example 1 on previous section, which is on page 971. Here's the function itself, the orange one, and the blue one is the parametric form of the function y equal to x squared minus 1. So what we did in example 1 is that we let x equal to t, okay, and y equal to t squared minus 1. So as you can see, when you type it in with the parentheses, the first one is the x position, the second one y position, and I had t go from minus 2 to 2. As you can see, the blue curve is right on top of the orange curve. That's why you only see part of the orange curve, because the blue curve is exactly the same as the orange curve, except that the blue curve, I only let it go from minus 2 to 2, so it stopped. Because the parametric equation, it's dependent on where you want t to be. Okay, once your t stops, then the curve just stops right there. Whereas the original equation, it goes on from one side to the other forever. So that's example 1. Example 3, that I also plotted the parametric form right down here. As you can see, it is just a matter of this is a linear equation, and we parameterize. I don't remember what we did, okay, frankly. But anyway, that's the x value, 2t minus 5, in example 3, and that's the y value. And when you type it in and let t go from 0 to 4, then here's the graph. So that is example 3. So please do this yourself too, okay? All you have to do is just type in 1 or 2 functions, and then your problem is done, and then you can see your beautiful little graph. So here's example 4, same principle, where we have, in example 4, we ended up we started out with x equal to t squared plus 1 and y equals to 2 plus t, and we were supposed to find this equation. As you can see, they are the orange one is right on top of the black one. Okay, they are exactly the same, which means our goal there was actually to find the regular equation instead of the parametric one. And so this graph then proves that we got the right answer. Okay, they better be the same, otherwise something odd is happening. And here's example 5, and that we did last time. Okay, x equal to e to the minus t, y equal to 3et, and when we were done calculating, it turns out to be y equal to 3 over x. And as you can see, that's the black curve is y equal to 3 over x. And the orange curve is the same thing, except t is only allowed to go from 0 to 2, and that's what you get when that happens. And if you let t to go longer, it will go down farther, and you should try to do so too, okay, to see how that works out. And so next, let me see right here. We have, I have example 6 here. And so please also do this yourself. But I'm showing you the stuff that I typed out so that you can compare to it. Okay. Specifically example 6, don't forget to put in these parentheses. If you don't, your answer will be wrong. And that is the log of x minus 2 squared. The whole thing has to have parentheses around it. And even though in the book there's no parentheses, but when you type it into decimals, you must have those parentheses. Otherwise, you'll take it to mean something else. It mean the whole log of x minus 2 is being squared, I guess. So, and then of course the orange part is the parametric equation, okay, and the black part is the regular equation. And as you can see, the orange part sits right on top of the black part. However, I only have the orange part going from t equal to 0 to t equal to what, 20 or something. So it only goes on one part of the black graph, which is not surprising. Parametric equations only go as far as you allow the t to go. Okay, t controls which way, how much x is moving and how much y is moving. T is basically the restraint. Next, let's look at example 7. Okay, same deal. We had some equation that turns out to be an ellipse, and here it is. And then remember that you can let t be very, very small. And so my t here only went up to pi. Okay, you should have t start at maybe from 0 to 0.1 to see where it started crawling, and then increase the t to say pi, so you can see half of it, and then eventually you can increase t. So at pi only got half, so you can change the pi to 2 pi, then it will draw the entire ellipse. Okay, very nicely. Look how beautiful it is. All right, so that is that. And then for homework, the first problem I did is problem 15, which is some kind of absolute value function. And as you can see, the absolute value function can be typed in as well. Okay, just type the vertical bar, which is on your keyboard as well. On a keyboard, you have to push Shift backslash. Okay, that's the vertical bar, and decimals understand it to mean absolute values. It is so intelligent. Okay, and it's so that is totally awesome. And then that's problem 15, and here's problem 33, which we have. What is that? Oh, who cares? The point is some kind of a graph. It looks to me like what is it called? We don't care right now. It just we have a parametric function, and it gave us this thing. Okay, so that is that. All right, so next we have that is problem 15. That looks somewhat cool, and not that much actually. Problem 47 looks cooler. Okay, with that thing swinging around like that and look like a figure 8. All right, next. So next, here's problem 54. I guess showing it like this is perhaps just as good. So problem 54 has that cool looking shape, and you're supposed to guess what these numbers are. Okay, so I guessed it, and it come out looking just like the book once. So that should be right. And then problem 71, of course, looks very neat. Is all those things twisting around. Not sure what it's good for, but it looks very, very nice. Okay, and that is the end of this section.